The theory that the universe was created by the Big Bang is intriguing. According to Einstein's theory, that is. You could call that textbook cosmology. However, according to the present textbook, the universe went through a period known as inflation before the Big Bang, which, if you consider the Big Bang as the hot, dense phase from which the world appeared, sort of burst forth 13.8 billion years ago. We therefore believe that the cosmos was expanding rapidly before that. It indicates that its size was constantly doubling, and the figures seem absurd. In less than a millionths of a second, we believe that a universe that was smaller than a single atom would be far larger than the entire observable universe, which contains 350 billion galaxies. The expansion was exponentially quick. When that ceased, all of the energy that was propelling that expansion was released into space, heating it up and creating the matter particles that make us up, as well as everything else that we see in the sky. This is what we call the Big Bang. That may sound fantastical, yet that is now accepted cosmology. What caused the inflation, then, is the key question. What prevents inflation? What was the duration of the inflation? We're not sure, is the response to that. We're not sure. The current atoms, molecules, stars, and galaxies were created from an infinitely dense, small ball of matter that began to expand in the beginning. However, what existed prior to the Big Bang? How did the universe seem before? Well, everything. In the span of a single second, the universe doubled in size, a phenomenon known as cosmic expansion. The universe was left frigid and barren by this fast inflation, which was fueled by an enigmatic force that pervaded empty space itself. Only then did the Big Bang's hot, dense circumstances become apparent. According to some of those theories, inflation doesn't halt all at once. There are patches where it stops, and you receive a universe each time it stops. According to some of these theories, known as endless inflation theories, there may be more than our world, the portion that is visible to us, and they may be constantly being created. Indeed, there may be an infinite number of universes. What then should we make of that? However, contemporary cosmology is located there. The ultimate answer to the question of our origins may be beyond the realm of science, if cosmic inflation accurately explains what transpired before to the Big Bang. But since we don't know anything about what happened before inflation, and it's unlikely that we ever will, that only serves to raise more questions. As I indicated, there are currently ideas that posit that there could be an endless number of universes. Isn't that an incredible concept? I should also add one more item. According to some of those hypotheses, if such is the case, the so-called constants of nature, therefore factors such as particle masses, light speed, and gravitational strength, can differ from universe to universe. Then you wonder, well, why is our universe so conducive to life? Why do stars produce the ingredients necessary for life? Carbon and oxygen. How come everything is so perfectly balanced to support life? In these situations, the response is that, well, all universes exist. There are worlds with every imaginable combination of the laws of nature. Therefore, it goes without saying that we must see a universe that permits our existence. However, one could inquire, well, how likely is that? The explanation is that, since there are an infinite number of universes, it is unavoidable that there will be an endless number of them. I emphasize that this is highly speculative material, but the first point I made on inflation, that there was an exponentially rapid expansion prior to the Big Bang, if you will, is not speculative. That is the cosmology of the mainstream. Although it is more theoretical, the theory that it might result in numerous universes is still supported by science, and researchers are looking into it. And once more, study in this area is ongoing. According to inflation, the epoch before the Big Bang was incredibly cold and devoid of anything but empty space, and the energy that carried the cosmos into its original state prior to the Big Bang and out to this vast magnitude was contained in that empty space. In addition to cosmic inflation, there are several hypotheses that explain the causes of the preconditions that led to the Big Bang. According to one theory, the cosmos might have other dimensions. So let's pretend that we just have a piece of paper on which to live. According to certain beliefs, there may be more than one universe floating around in addition to our own. We are merely floating on a sheet in this larger multiverse, which has more spatial dimensions. The topic of what occurs when they collide together can then be raised. According to one theory, the Big Bang was actually generated by the collision of two sheets, or what are known as branes, which separated after colliding. Additionally, they heat up as they collide, creating what appears to be a Big Bang on that sheet of space and time, if you will. Thus, That is an alternative explanation for the events leading up to the Big Bang. Statements like multiverse theories and brains colliding into each other giving rise to Big Bangs may seem wildly unrealistic and speculative. However, they are supported by mathematical reasoning. Furthermore, there is experimental evidence to support ideas that describe the universe's extremely early condition. The good news is that we are currently taking measurements. I should point out that the cosmic microwave background radiation, or CMB, provides the experimental foundation for all of this. Thus, the oldest light in the universe is visible when we gaze up at the sky. 380,000 years after the Big Bang, it was released. When the universe cooled enough for atoms to form, that is, the universe turned translucent at that moment, and light has been moving through it ever since. Additionally, we currently have a European satellite called Planck in orbit that has been obtaining in-depth images of this light. It's like a baby picture of the universe in that light. In a way, it's like a baby scan of the universe. As a result, you can observe the cosmos in its earliest stages and notice various structures and characteristics of that light, which provide you with a hint as to what transpired at the beginning of time and the universe. And that's where the experimental evidence for these theories comes from. Einstein's general relativity and quantum theory are the two main tenets of contemporary physics. Combining Einstein's theory with quantum theory is crucial to comprehending the Big Bang's origins and how it occurred. We won't be able to address the fundamental problems of cosmology, such as what space is, unless we have such a theory. What time is it? What is the universe? And from where did it originate? The observable cosmos spans 94 billion light-years vast, with the farthest objects in the universe located 47 billion light-years away. The cosmos has been expanding over the universe's age, which has caused very distant objects to be farther away from us than their light travel time. This is the reason why the observable universe is greater than the time it takes for light to travel. The majority of scientists believe that the cosmos is much larger than what can be seen. However, is there anything outside of the cosmos? Beyond the universe, is there anything? Most likely not. We have a strong suspicion that the cosmos, including our portion of it, may be infinite in size. If we only consider our own universe, we can be certain that it extends well beyond what is visible to us. What makes me say that, then? If you think about it, the universe, or at least our portion of it, has existed for 13.8 billion years. Accordingly, light has only had 13.8 billion years to reach our eyes from the portion that is visible to us. Thus, our vision is limited to the distance that light has had time to travel. However, based on observations of the universe's structure and curvature, scientists believe there is much more to it than that. Therefore, it surely goes beyond the small, visible bubble. Another important question is how far it extends. We don't know, but its scope might be endless. We have made an effort to provide answers, taking into account the most recent physics observations and discoveries. What existed prior to the Big Bang? How large is the cosmos that we can see? And what is out there? Are we overlooking something, though? A crucial query that inevitably comes up as we inquire about the origin of everything. What is the end of the universe? As of right now, the best estimate, or guess, is that it will continue to grow indefinitely. And the reason I say that is because the expansion of the cosmos is truly speeding. It is a big enigma because, prior to that finding, we believed that gravity was always alluring. Given that the universe has been expanding since the Big Bang, and that there are so many galaxies in it, it should at least be slowing down. The topic of whether it contains enough substance to slow it down to the point where it stops and recollapses was even raised. However, the recent finding that the cosmos is expanding faster than previously thought implies that, barring the emergence of some new physics that we do not yet comprehend, the universe will continue to expand indefinitely. Thank you for viewing. Was this video enjoyable to you? Then, to ensure that you never miss films like these, show your support by subscribing, ringing the bell, and turning on notifications.